Hey, Mike, we're going to be ready to go right away. The shot went off about a half an hour ago, and we got to 45% at 5 inches.
Well, that should be good.
Okay. You know,
Hey,
we're also going to need
Dave,
to...
that D10 is coming in for engine work today. Master Control knows.
Okay, good. Thank you. Good.
Welcome to the future of mining. I'm Tom Geich. We've set up a special link to the command center for a major mining operation. But the nearest mine site is 350 miles away. And that mine, well, in fact, all the mine sites controlled through the command center are unlike anything you've ever seen. Because today, we're looking ahead to the year 2013 and exploring the soon-to-be realities of autonomous mining. Now, Dave McKinnick is the operations manager at the command center. Hey, Dave.
Yeah.
Got a minute?
Yeah, just about exactly.
Can you tell us a little bit about your operation?
Yeah, sure. We manage 8 mine sites in the northern U.S. and Canada, including open pit and underground copper, nickel, and molybdenum mines, with 6 active sites and 2 of them in reclamation.
What kind of equipment are you running?
Well, each site has something like 35 autonomous trucks and a completely automated drilling fleet. Each site also has 7 or 8 manned loading tools, and well, we have fleets of remotely operated CAT, D10, D11 dozers, some of them working around drag lines.
How far away is your most remote site?
Well, I don't know, maybe 800 miles or so. It's way up north in Canada. It's someplace you don't want to be if you don't have to. Trust me.
Okay. But that was pretty much the driver behind your move to autonomy, wasn't it?
Well, that and safety. Look, like everybody, we're pushing into more remote areas because that's where the reserves are. And yes, as you do that, it does get harder to find people who work there. But safety's the biggest benefit to autonomous mining. The more people we can move out of the mine and into an operations center like this, especially considering the extreme environments we have to work in, the better it is for everybody.
Yeah, this would be a more comfortable place to work for sure, but it looks pretty complex. What does it take to actually make a mine site autonomous?
Well, here's the best person to answer that question. This is Cheryl Hamada. She's our Chief Technology Engineer.
Dave, we need to talk about the drills at the North Dam site.
Yeah, let me handle some things first, and then meanwhile...
Hi, Cheryl. Hey, can we ask you a few questions about mine site autonomy?
Sure. What do you want to know?
Well, for starters, what does it take to run a fleet of autonomous trucks?
That is a bigger question than a lot of people might think, because an autonomous mine site is a lot more than autonomous trucks. I mean, it's one thing to make a truck that can navigate a haul road, but it also has to be able to work as part of our entire system. I mean, we've got a lot of equipment out there, and it's vital that each asset knows where every other asset is and what it's doing.
An asset being what?
Anything from a drag line to a single person on foot. The goal is to achieve what we call integrated site awareness. That's one reason why we run mostly CAT equipment.
Because Caterpillar makes all the different types of equipment, from trucks to graders to dozers.
And they've also developed lots of mining information technologies too, like MineStar, MineGem, CAES, AQUILA. See, one thing people don't understand is that an autonomous mine site is hugely information intensive. We constantly send instructions to the equipment. The equipment communicates back to us.
About what?
About speed, payloads, production, fuel levels, site conditions, machine condition. Then all that data is gathered and analyzed and turned into actionable information for the next set of instructions. It's a continuous information cycle.
And you coordinate it all there at the command center.
Oh, we do the overall site management. The autonomous trucks have their own onboard intelligence, so they micromanage their own operations. The command center sort of functions like the conductor of an orchestra. The players act on their own, but our people and systems bring everything together. The goal, of course, is to make the mine as efficient and productive as possible.
Wow. An autonomous mine site is a lot more than just driverless trucks, huh?
Absolutely. For one thing, it takes a major investment in information infrastructure, like high-precision GPS and broadband wireless communications. We're building high-speed fiber optics links to our sites now, too, to make communication even faster. So, in the end, information and process management form the big picture.
And the autonomous trucks are just a piece of the puzzle.
Right. Autonomous mining is all about gathering, managing, and processing information, which is actually a much bigger job than just making trucks run by themselves.
Okay, well, that makes sense. But how do you get a truck to navigate a haul road on its own?
You know, you need to talk to Dan Bryson, one of our autonomy engineers. He can tell you all about autonomous equipment.
Okay, well, thanks, Cheryl. All right, so Dan Bryson is our man. Hey, Dan.
Oh, hey, how you doing today?
Great. Got a couple of questions for you.
Okay.
First, how long have the autonomous trucks been around?
Let's see. We got our first trucks last year, and before that, we had our first autonomous drills.
Oh, so the drills came first.
Yeah. Well, drills move slower, and they work in a more confined area, so it's a little bit easier to apply the perception technology to them.
Is perception just what it sounds like?
Yeah, it's the vehicle's ability to look at its environment and recognize what it sees. It's pretty much the key to any autonomous tool. Caterpillar already had the automated drilling technology in place with the AQUILA. All they had to do was add the perception and auto-tramming, which is way more complicated than it sounds.
Okay, well, I suppose. So, when did autonomous equipment become a practical reality?
Well, Caterpillar put the first underground mine gem system to work, I'd say about 8 years ago. But we started seriously considering using autonomous trucks after the 2007 DARPA challenge in California.
Okay, let's see, that's Defense Advanced Research Projects Agency?
Right. It was the U.S. Defense Department program that encouraged industries and universities to develop autonomous trucks, autonomous vehicles, if you will. Caterpillar cleaned up in 2007. They came in first with Carnegie Mellon and finished third with Virginia Tech. You know, and the thing about the 2007 challenge was that all the vehicles had to navigate through an urban course. So they had to do a lot of the same tasks that they had to do at a mine site, such as navigate through roads that are subject to change, avoid obstacles, maneuver through traffic, that kind of stuff.
Now, how do they navigate?
Well, any autonomous vehicle has to take in a lot of sensor data and then process it fast enough to plan a route and make any adjustments. That starts with the perception thing I mentioned on the AQUILA drills.
Sure.
And perception on the CAT trucks involves using data fusion and dynamic sensor arbitration to produce a 3D traversability cost map.
Okay, well, wait a minute. How about in plain English, huh?
So I guess that's just a fancy way of saying that the trucks know where they can and where they can't go. All right? They also work with things like high accuracy pose estimation and real-time replanning, which is how CAT trucks navigate around obstacles. Now, the DARPA vehicles that CAT worked on had that kind of discrete planning capability down cold. Even in 2007, they used what's called high-level reasoning and a logic engine, which let those vehicles predict where other traffic would go and then how to avoid it. And it was pretty cool stuff, let me tell you.
Okay, how about radar? Radar must be involved somehow.
Radar sensors are one part of the perception equation of an autonomous truck, but it can't be the only part. By combining a number of different kinds of sensors, the CAT truck creates a much crisper picture of the world. Think of it like replacing your old 1960s TV with a brand new flat-screen plasma. It's better, sharper, it's a lot more detailed. Well, that lets the logic engine guide the CAT trucks more safely around the obstacles instead of just coming to a stop. And any single technology just wouldn't provide enough information to make the trucks work as a part of the total mining system.
A system that includes autonomous drills, like you said.
Right. And the AQUILA drills are especially interesting because they provide us with so much site planning data.
Site planning. Now, what do you mean?
Well, all right. Feedback from the drills gives us a lot of information about the underlying geology of our site. We use that information to create more effective drilling patterns so we can get the consistent fragmentation that we want.
Because good fragmentation speeds up the operation.
Right. And it's a lot easier on the loaders and stuff.
Well, that's valuable even beyond the efficiency and safety factors, huh?
And I can't stress the safety value enough. That's actually one of the biggest payoffs. Fewer people on a site means fewer chances for an injury.
Sure.
And one of the other ways we minimize the number of people on a site is through remote operation of some of our Dozer fleets.
Now, can we take a look at that?
Yeah, let's see. Mike, are you busy right now?
Not for a bit. They're just checking a shot.
Is it cool if they come take a tour of your workstation?
Sure. Hey.
So, Mike, what do we have here?
Well, it's essentially a big version of the joysticks for a radio-controlled model car, except I'm controlling a D10 that's 300 miles away. Wow. And my view of the work site isn't limited by what my eyes can see.
What, it gives you X-ray vision or something?
I have screens that give me a full view of the work site, plus a lot of other information, too. We call it augmented reality.
Augmented reality, huh? Okay.
There's cameras on the Dozers which transmit real-time images, which is what you'd expect. But also, I get to see things like avoidance zones. That's this crosshatched area here. Or if I'm working near another piece of equipment, the screen will show me exactly where it is. The system also helps me to avoid places that have been drilled, or it might tell me how a drag line is moving so my machines don't get hit by the boom. Lots of stuff.
Machines? Now, wait a minute. Do you control more than one machine at a time?
Well, it's easy for me to switch from machine to machine, so if I need to work a stockpile in Wyoming in the morning and move shot rock in the Yukon in the afternoon, I can do that. I don't even have to put on a warmer coat.
Nice.
Hey, Mike, look, one of your D10s is going in for an engine service tomorrow morning.
Oh, yeah, I saw that. Thanks.
Now, how did you know about the service schedule?
Well, the machine told me.
Actually, it sent an alert last week about a failing injector.
We get lots of machine health information.
Well, that sounds interesting.
Sia can actually tell you a lot more about that. She's our predictive analysis engineer, and I kind of have to get back to work.
Okay, thanks for the information. Predictive analysis?
Predictive analysis service. Yes, it's one of the main tools we use to monitor our equipment.
It's a form of condition monitoring, then?
But it's a very sophisticated condition monitoring service offered through the mining company's cat dealer. And in fact, that's who I work for.
Oh, so you're a cat dealer expert working on site?
Right. I'm embedded here to act as a liaison between the mining company and the Cat Predictive Analysis Service Center.
Great, very good. So what makes predictive analysis more sophisticated than other condition monitoring techniques?
Well, basically, it's the number of machine parameters it takes into account and the way it analyzes the data. Take the D10 that I just mentioned. You know, before we used predictive analysis, we might have had to wait for that injector to fail, and we probably would have spotted it by looking only at the exhaust stack temps.
Probably would have saved the engine, too. Sounds like good, solid condition monitoring.
It is, but predictive analysis goes a step further by spotting problems like faulty injectors well before they actually fail. Now that's particularly important at an autonomous mine site because the trucks have to come in on their own for service.
Now, how does predictive analysis help them do that?
Well, by monitoring all the sensor data from the machine at once, and then it uses a mathematical model to predict what will happen when it sees combinations of parameters going out of normal.
Sounds complicated.
It is, but the analysis is done at the Cat Predictive Analysis Service Center. The engineers there work with the cat dealer and the customer to provide recommendations which are based on rules that they've developed for each machine. You know, that way we get warnings a week or more in advance. Well, at least for problems that we've dealt with in the past.
Okay, well, what about the stuff that you've never dealt with?
Well, the predictive analysis engineers help define what the problem is, and then they'll update the model. Now, that allows them to predict that specific failure if the problem crops up again.
So the longer you use a model, the more accurate its predictions become.
Precisely.
Thanks, Sia.
Do you have the data on the D10 for me, please? Thank you.
Hey, Dave.
Oh, learning what you need to know?
Well, we've gotten a good first look at how an autonomous mine site works. How long did it take you to get to this point?
Well, we've been laying the groundwork for autonomy for a few years, building up our information infrastructure, adding CAT products like MineStar, CAS, AQUILA, and learning how to take advantage of services like predictive analysis. So when Caterpillar made the remote control and the autonomous equipment available, we were ready.
So, has autonomy changed the way you mine your sites?
Absolutely. There was a lot of change management to do along the way, but now we don't see how we could be as efficient or as profitable without the autonomous systems.
Excellent. Well, okay, Dave, thanks for your time.
You're welcome.
So, there you have it. A look ahead to the days of autonomous mining. They're coming sooner than you might think, so now is the time to begin laying your groundwork. Make sure you talk with a CAT mining technology representative on how to get started on your journey to autonomous mining.